Come with me on a mission to outer space. Our destination is the planet Mars. We have to travel over 300 million miles. That may seem like a long trip, but we'll be speeding through space at 13,000 miles an hour. Welcome to On a Mission, a podcast of NASA's Jet Propulsion Laboratory in Pasadena, California. I'm Leslie Mullen. I'm a science journalist, and I arrived at the Jet Propulsion Laboratory, also known as JPL, 2 years ago. The lab is a jumble of buildings at the foot of the San Gabriel Mountains and just down the road from Hollywood. But at JPL, they're focused on stars of a different sort. JPL is like a little town, but a town full of scientists and engineers who study the mysteries of the universe and build robots to send to outer space. In my short time here, I've discovered there are a million stories to tell. The concept of this podcast is to take a close look at a single space mission and examine it from different angles. To share the science, yes, but also the struggle and satisfaction in getting a mission off the ground. For this first season, the focus will be on the InSight mission to Mars.
Go Atlas. Go Centaur. Go InSight.
8, 7, 6, 5, 4, 3, 2, 0. Liftoff of the Atlas V, launching the first interplanetary mission on the West Coast, and NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
A rocket carrying the InSight mission launched from Vandenberg Air Force Base in California earlier this year, on May 5th. It is now on its way to Mars, due to arrive at the end of November. After it lands, the robotic suite of instruments will peek below the planet's surface, investigating the different layers that make up Mars. You may already know that Mars is the fourth planet from the Sun. Earth is the third planet from the Sun, so Mars is a little farther out than we are. On a clear night, when you can see the stars, you may have noticed one that looked a little reddish. Sunlight bouncing off the Martian red rocks makes it look just like another star. But Mars is a world, a harsh, desert, alien world. Over the years, NASA has sent many spacecraft to Mars, but it's still a mysterious place in many ways and one that we've only just begun to explore. But Mars does not welcome visitors with open arms. Many spacecraft have died trying to get there. So far, there have been 43 robotic missions sent to Mars, many from the US, but Europe and Russia and even India and China have tried to go there. The current record for Mars missions is 18 successes and 25 failures. Granted, some of those failures can't be blamed on Mars. Some missions, especially early on, came to an abrupt end due to rockets blowing up on the launch pad or not getting very far past Earth. But still, less than half of the missions ever sent to Mars have made it. The InSight mission hopes to improve the odds. Soon after InSight launched from Earth, on Mars, one of the biggest dust storms in history swirled into life.
Dust storms tend to pop up on Mars on a pretty regular basis. In fact, there's a dust storm season on Mars. In some seasons, there's small dust storms. In some seasons, there are huge dust storms. And we actually just got hit with one of the big ones.
That's Bruce Bannert, the scientist leading the InSight mission. He and the InSight team were first alerted to the storm from the Mars Reconnaissance Orbiter, a satellite circling Mars. A rover on the ground, named Opportunity, sent photos back to Earth of the Martian sky growing dusty and dark until the sun disappeared in the sky. The storm grew until it covered most of Mars. We don't have weather like this on Earth. Our storms are located in one place, and then they drift to another area or disperse entirely. We've never, for instance, had a hurricane in the Atlantic Ocean grow and grow until it becomes a single storm, enveloping most of the planet. But this is not the first time we've seen such a large storm on Mars. When NASA's Mariner 9 orbiter reached Mars in 1971, it saw a global dust storm that was so immense, only the tops of the tallest volcanoes could be seen peeking above the haze. The Mars Global Surveyor satellite witnessed a similar massive storm in 2001. Those orbiters saw the storms from high above. The Viking 1 lander in 1977 was the first time we got to see such a big dust storm from the ground. Because Viking was actually in the storm, it also could gauge the force of the winds, which topped 60 miles per hour. Some of you may be thinking of the movie The Martian, which saw Matt Damon's character knocked down by a raging dust storm on Mars.
1,200 kilometers in diameter, bearing 24.41 degrees.
That's tracking right towards us.
Based on current escalation, estimated force of 8,600 newtons.
What's the abort force?
7,500.
Anything more than that and the map could tip.
Begin abort procedure.
Let's wait it out.
Prep emergency departure. We're scrubbed. That's an order. Visibility is almost zero. Anyone gets lost, hone in my suit's telemetry. You ready?
Ready! Commander, are you okay?
I'm okay!
It makes for good drama, but the air is so thin on Mars, only 1% as dense as air on Earth, that even the strongest winds wouldn't knock you down. In the movie, the roaring winds that rock their spacecraft and force them to abort the mission would actually feel like a gentle breeze. To understand how such strong winds wouldn't feel strong, imagine you're at the beach. A wave comes up and knocks you down. The wave is moving slowly compared to the air, but because the water is so much more dense than the air, it doesn't take much to lift you off your feet. The opposite is what happens with the thin air of Mars. Although the winds there don't pack a punch, they are able to pick up fine dust particles and loft them high into the air.
Mars dust is extremely fine, and it's very easy to lift up in the atmosphere. And without any moisture to have the dust particles clump together, it takes a long time for it to settle out. So these dust storms tend to kick up really fast and then die off really slowly. And even after the wind's all gone, you still have a lot of dust up there, which is absorbing the sun and making it kind of dark down on the surface.
InSight has to enter the atmosphere of Mars, descend down through it, and land on the planet's surface. This is known as EDL, entry, descent, and landing. On Mars, the atmosphere is thick enough to burn you up on entry, but thin enough to make landing with a parachute extremely tricky. This is why Mars landings often include rockets firing toward the ground, so-called retro rockets that help slow down the descent. The InSight mission is prepared to go through entry, descent, and landing for a range of conditions, including a dust storm.
The little dust particles, when you're coming in at 15,000 miles per hour, they do act as a little bit of a sandblaster. And when we designed their spacecraft, we knew that we were coming in during dust season, so we actually added about a half an inch of extra material on the heat shield, the ablative material that actually burns off as you go into the atmosphere. The calculations and experiments that we actually did on the material indicated that, that was more than enough to accommodate the extra erosion that we would experience if there was dust in the atmosphere. So even if there is still dust in the atmosphere when we land, our entry system should be perfectly happy with that kind of environment, and the parachute won't even notice it.
It can take months for dust from such a big storm to slowly settle out of the air. If there's a lot of dust in the air when InSight lands, the biggest problem for the lander will be power generation. InSight runs on solar power. Falling dust not only blocks the sunlight, it also could coat the solar panels, causing InSight to run out of energy. Opportunity rover, who got caught in the dust storm, is also solar powered. It went into hibernation soon after the dust storm appeared in order to save power. The power does more than run the rover. It keeps it warm on frigid Martian nights. Temperatures in Opportunity's neighborhood, the Martian equator, can dip down to negative 130 degrees Fahrenheit or negative 90 Celsius. Without a heater, the rover could freeze to death. It's similar to running a car in the winter, so the cold doesn't sap the battery charge. The Martian cold may have been what ultimately killed Opportunity's twin rover, Spirit, back in 2010. Opportunity is currently the longest-running mission on the surface of Mars. It's been in operation for over 14 years, since 2004, and it survived a large dust storm in 2007. That storm led to 2 weeks of minimal operations, including several days with no contact from the rover, in order to save power. Opportunity has been in hibernation now since June 10th. Dust storms do heat the air up on Mars, so it's possible Opportunity wasn't fatally damaged by the cold. In September, enough dust had settled out of the atmosphere that sunlight could penetrate through the haze and recharge the solar panels. While waiting for the rover to wake up, to boost the team's morale, engineers have started each day playing a song in mission control.
Wake me up before you go, 'cause I'm not.
Wake Me Up Before You Go Go by Wham is just one of many songs dedicated to the sleeping rover.
Take me dancing tonight.
Over the weeks, their themed playlist has included I Will Survive by Gloria Gaynor, I Won't Back Down by Tom Petty, Here Comes the Sun by the Beatles, and Dust in the Wind by Kansas.
All we are is dust in the wind.
Opportunity, meanwhile, remains silent and still. Mission engineers will keep listening for the rover to phone home over the next few months. What InSight will have to struggle with when it arrives on Mars is still to be determined.
We have a lot more solar power generation capability than Opportunity, but I think that our design would be at best marginal against the darkest part of the dust storm. Once we get to Mars, if we have a dust storm like that again, it would be pretty nerve-wracking for us.
Nothing lasts forever but the earth and sky.
InSight science lead Bruce Bannert has had his heart broken by Mars before. Years ago, he worked on the Mars Observer mission.
My early career, I sort of was a recluse. I'd kind of go in my office and I'd lock the door and just, work on my computer and hope nobody ever bothered me. But then somebody came and said, well, we need someone to work on this space mission, or we need a scientist to help integrate this altimeter that's going to go to Mars on Mars Observer.
An altimeter is used to create elevation maps that show the heights of mountains and the depths of canyons.
This was going to be the first detailed elevation map of any planet outside the Earth, and it's something that's really critical if you want to look at what forces there are on a planetary crust. And, by the time we launched, I thought, well, finally, we're going to Mars and all our problems are behind us. And then we got close to Mars. We did our last sort of trajectory correction maneuver before going into Mars orbit, and we never heard from it again. Back in, what was that, 93, I guess, which is when this was all happening, we didn't have the fancy displays and the animation. So when we had to turn the spacecraft to do this orbit trajectory change maneuver, we slewed away from the Earth point on the radio, so we lost contact. It was supposed to fire its rockets for 40 seconds or something like that, and then turn her back around, and then we reacquired the signal. We had an old CRT monitor hooked up to the DSN data feed with the signal strength that just is a line across, sort of like one of those old oscilloscope displays. It turned away, and then so the line goes flat at zero power. At 20 minutes or 40 minutes later, it's supposed to blip back up again and show our signal line. One of the young engineers on the project was like, keeping track of the time, had his pencil there on the screen, says, right about here is where we ought to get it. We were kind of watching, and it kept on going flat, and I said, well, maybe we're having a little bit of trouble acquiring, and so you're just waiting for something to happen, and it's not happening, and it's not happening. And at first there's lots of explanations why that might not be true, and then there's fewer explanations that are still consistent with it being that long, and then maybe there's one or two things that might have gone wrong that are still not fatal, but it's a slow motion train wreck that you're getting sort of more and more of a sinking feeling and trying to stay optimistic, but there's always a voice in the back of your mind going, oh, this isn't good. We waited to acquire the signal, and it didn't show up. That flat line never did leave zero. That was a really, really horrible feeling to, have worked on something for 5 or 6 years, and then suddenly, it's all gone. And later on, they found a design flaw in the propulsion system, which likely allowed the fuel to mix with the oxidizer in the wrong place and probably blow a hole in the side of the spacecraft. When Mars Observer was lost, we took sort of the same payload, or part of the same payload, and started a new mission with kind of the same designs but a little bit different spacecraft called Mars Global Surveyor, which launched about 4 years later. It kind of just merged from Mars Observer into Mars Global Surveyor. I ended up actually working on that project for about 20 years. And it's a great project. I mean, the MOLA maps of Mars, and if you've ever seen the map that's kind of blue and orange, that's our MOLA elevation map that, I played a small part in helping to create. So these are like the first really high resolution images that we had of Mars. Sort of started revealing, the actual geology of Mars at a level that can kind of visualize as a human being and not as somebody flying, in an airplane, 2 miles up or something. And that's been one of the foundational data sets for Mars for understanding all kinds of things about that planet. That was an amazing project. That was so much fun.
As Bruce notes, although Mars Observer failed, the design was reused for the successful Mars Global Surveyor. Spacecraft are often made this way. InSight, for instance, is essentially using the same architecture as the Phoenix lander that made discoveries near the Martian North Pole over 10 years ago. The Phoenix lander, meanwhile, rose from the ashes of the Mars Polar lander that crashed in 1999. Rob Grover oversees the entry, descent, and landing procedures InSight needs to go through in order to land on Mars.
We can't really do full testing on Earth because the gravity is different, the atmosphere is different. We use simulation for making sure that we're going to be successful when we land on Mars. And we use a method called a Monte Carlo simulation, which it's named for a game of chance, which is a little bit of kind of like what EDL is. So when we run the Monte Carlo simulation, we actually land 8,000 times, and it provides us kind of statistics on how we'll perform. We randomize all the parameters that are used in modeling the landing, like the mass of the lander and how well the rocket engines are working. And for each type of atmosphere we think we're going to land in, we run a Monte Carlo. And each flight path angle or angle we're going to hit the atmosphere, we also run a Monte Carlo too. So we have actually close to probably 1,000 parameters. And that allows us to practice the landing under multiple conditions. We do many, many, many Monte Carlos. A single landing we've run probably millions of times probably at this point over the 5 or so years that we've been doing this. There's a little bit of rolling the dice on EDL, but we try to account for everything we possibly can. It's a risky part of the mission, probably one of the riskiest 6.5 minutes of the mission. As EDL engineers, our job is really to try to think of every possible thing that can go wrong, everything that Mars can throw at us, and try and model that and make sure that the system will be able to handle that on landing day. InSight is the first mission to land during dust storm season, and that makes it particularly challenging because the atmosphere it affects the landing quite a bit. And with the dust storm season, we could be landing in the middle of a global dust storm, or the atmosphere could just be a regular clear atmosphere, or anywhere in between. And that makes a lot more variation that we have to account for when we're designing and executing the landing. So it makes it more challenging for InSight than past missions in that respect.
As InSight approaches Mars this November, we'll all be on the edge of our seats, watching for that signal, waiting to see if it beats the odds and survives. But InSight almost died before it even left Earth.
We had a lot of problems with InSight, and then we had to stand down from our launch in December of 2015, which was incredibly disappointing, and it was really a dark time. So it's almost Christmas, and then we had to give up suddenly on this mission.
More about that next time. If you like this podcast, please rate us on iTunes and SoundCloud, and share us on Facebook, Instagram, and Twitter. We're #NASA on a mission. Also check out NASA's other podcasts, Gravity Assist, Rocket Ranch, What's Up, NASA in Silicon Valley, and Houston, We Have a Podcast. They can all be found on NASA's podcast page or on most podcast platforms. We're On a Mission, a podcast of NASA's Jet Propulsion Laboratory.